In this presentation, we will learn how to delete the last node of the circular doubly linked list. So let's get started. Now here comes the initial state of the circular doubly linked list. Tail pointer is currently pointing to the last node of this list. Now, our target is to delete this particular node, okay? We want to delete this node of the list. That is the last node of the list, okay? For this purpose, first we will declare a temp pointer. Then we will assign tail prev to it. Let me tell you, this time we will assign tail prev to it so that it can point to the node just before the node we want to delete. That is the last node of the list. We want to keep a temp pointer to the second last node of the list. After this, we will update the next part of this node so that it can point to the first node of the list. For this purpose, we can write this line of code. Temp next equal to tail next. You can see over here that it is now updated. Then after this, we will update the prev part of this node so that it can point to the second last node of this list instead of the last node of the list. Now, how to access this particular node? We can access it through tail pointer. That's not a problem. Tail next prev equal to temp will update the prev part of this node. Here you can see it is updated by the address 2000, which is the address of the second last node of this list. After this, we can free this node without any problem because the links are now updated. So let's just free this node. And after this, the last step is to update the tail pointer so that it can point to the new last node of this list. For this, we have to write this line of code, that is tail equal to temp. And you can see over here, it is now updated. And obviously, the time complexity is constant because here we have only these lines of code and there is no loop involved. That is why it is big O of 1. Now let me just show the complete code in code blocks. So here is the complete code for deleting the last node of the list. Here we have struct node, we have add to empty function, add attend function. These two functions are required for creating the list. After this, we have del last function. It just needs tail pointer. Here you can see a temp pointer is declared, and here we are checking this condition. If tail is equal to null, then we will simply return tail. That means if there is no node in the list, then we will simply return null or tail. If temp is equal to tail, that means if there is just one node in the list, then simply free the tail. That means simply free that node, assign null to tail and return tail. Else we will perform this procedure which we have already seen, and finally we'll return tail back to the main function. And here you can see this is the main function where I'm creating the list. Apart from this, I'm printing this message list before deletion, and I'm calling this print function for printing the whole list. After this, del last function is called for deleting the last node of the list. And then finally again this printf function is called in order to print this message list after deletion. And finally the whole list is printed using print function. Now let me just execute this code. You can see over here that the list before deletion is 34, 45, 56 and list after deletion is 34, 45. Our code is working fine, isn't that so? You can check for the other cases as well. That means if there is just no node in the list, or there is just one node in the list, the code still works fine. Okay friends, this is it for now. Thank you for watching this presentation.